This linear generator runs on any fuel around the clock, in total silence, and it has almost no moving parts. It does not burn fuel with a flame or spin a turbine. It converts gas directly into electricity at over 90% availability, a reliability number solar, wind, and most fuel cells cannot match. Yet despite being backed by Bill Gates's Breakthrough Energy Fund, and already powering American grocery stores and data centers, almost nobody building off-grid has heard of it. It is called the Mainspring linear generator. By the end, you'll know what it is, how it works, and how to use it and what it saves you. Let's dive in. Right now, if you want reliable power that does not depend on the grid, the industry funnels you into two paths. Path 1 is solar panels paired with lithium batteries. Path 2 is a diesel or natural gas generator. Both of them fail you in ways that drain real money every single year, and neither one gives you the 24/7 reliability you actually need. Your rooftop solar system produces 0 watts from sunset to sunrise. That is roughly 14 hours of nothing during a December night in the northern half of the country. Your battery bank, even a premium lithium iron phosphate setup, costing $800 to $1,000 per kilowatt hour installed, loses roughly 20% of its usable storage capacity within the first 5 to 7 years. That is not a fringe complaint. That is published degradation data from the National Renewable Energy Laboratory in Golden, Colorado, based on accelerated cycling tests and field monitoring of residential installations. And if you go the generator route, you get noise, vibration, and a machine packed with pistons, connecting rods, crankshafts, rocker arms, valves, and hundreds of wearing parts on a fixed maintenance schedule. A typical 20 kilowatt standby natural gas generator from Generac or Kohler running continuously needs an oil and filter change every 250 hours. That is roughly every 10.5 days of round-the-clock operation. You are buying filters at $12 to $20 each. You are replacing spark plugs at $8 to $15 per plug every 500 hours. You are scheduling a certified technician at $75 to $150 per service visit, and every single one of those moving parts is a failure point waiting to strand you at 2 in the morning during an ice storm when the grid is already down. Now multiply all of that over a decade. A 20 kilowatt standby generator costs between $5,000 and $15,000 to purchase and install, depending on your region and local permit fees. Maintenance over 10 years of heavy use can add another $8,000 to $12,000, according to cost tracking data published by HomeAdvisor and verified by Angie's Contractor Network. That puts your total ownership cost north of $20,000 for a machine that shakes your garage floor and produces a 70 to 75 decibel drone your neighbors can hear a quarter mile away. And here is the efficiency number that really stings. A conventional reciprocating generator converts roughly 30 to 35% of the chemical energy in its fuel into electricity. The rest, 65 to 70%, exits as waste heat through the exhaust pipe and the cooling jacket. For every dollar of natural gas you feed that machine, about 65 cents heats the sky. That is the status quo. That is what the distributed generation industry considers acceptable. And when you hear what the alternative looks like on the inside, you will understand why no generator dealer brings it up at the quote appointment. The Mainspring linear generator replaces that entire mechanical circus with something that sounds almost too simple to work. Instead of pistons hammering up and down inside cylinders connected by rods to a spinning crankshaft, it uses a single magnet assembly that slides back and forth between air bearings inside a sealed tube. Picture an air hockey table. The puck floats on a thin cushion of pressurized air and glides with almost zero friction. Now imagine the puck is a powerful set of neodymium rare earth magnets, and the table is a tube wrapped in tightly wound copper wire coils. When that magnet assembly oscillates, it drives electrons through the coils, according to Faraday's law of electromagnetic induction, the same principle inside every electric guitar pickup and every utility-scale generator on the planet. That is the entire conversion mechanism. No crankshaft, no connecting rods, no turbine blades spinning at thousands of revolutions per minute. No spark plugs, no oil sump, no timing belt. Fuel and air enter the chamber from opposite ends. They compress together in the center until the pressure and temperature reach the auto-ignition point. This is compression ignition, the same thermodynamic principle that powers a diesel engine, but without a piston rod transferring mechanical force through a linkage to a rotating shaft. The expanding gas pushes the magnet assembly outward along the bore. The magnet rides on air bearings, meaning the moving part never physically touches the housing wall. That is why the machine produces almost no audible noise. There is no metal-on-metal contact. There is no lubricating oil needed, because there are no friction surfaces to lubricate. Now, if you are thinking that sounds too elegant to survive real-world conditions, engineers at Mainspring Energy spent over a decade refining and testing this exact mechanism, starting at Stanford University's Precision Systems Design Laboratory. The prototype work began around 2010 under the company's original name, Etagen Inc., before it rebranded as Mainspring Energy in 2019. The core physics is not exotic or unproven. Linear alternators have operated reliably for decades in demanding environments. NASA used free piston Stirling engines paired with linear alternators in deep space probe power systems beginning in the late 1970s. The SunPower Corporation, now a division of Ametek, built and delivered free piston Stirling generators and cryocoolers for NASA's Glenn Research Center in Cleveland, Ohio, throughout the 1990s and 2000s. What Mainspring's Stanford team solved was the specific engineering challenge of making this mechanism run continuously on cheap, commercially available fuels at a power output level useful for buildings and businesses. Each shipping Mainspring unit produces approximately 230 kilowatts of electrical output. To put that in household terms, the Energy Information Administration reports the average American home consumes about 30 kilowatt hours per day. One Mainspring unit could serve roughly 46 such homes simultaneously. The fuel-to-electricity efficiency sits in the range of 35 to 40% at rated load, competitive with the best reciprocating engines on the commercial market. But peak efficiency is not the real story here. The real story is what happens to your maintenance spending and your fuel optionality over the life of the machine. And that fuel flexibility angle is something you need to hear in full, because it fundamentally changes the economics of long-term energy independence. Here is where the Mainspring system leaves every conventional generator behind. A standard natural gas generator runs on pipeline-grade methane. If you want propane, you buy a conversion kit with different fuel jets. If you want biogas from a farm anaerobic digester, you need specialized fuel scrubbing equipment to remove hydrogen sulfide and siloxanes, a recalibrated engine tune, and often a written warranty waiver from the generator manufacturer. Hydrogen is even harder. Most reciprocating engines cannot safely handle hydrogen without significant retrofits because hydrogen's flame speed is roughly 6 times faster than methane's. That speed differential causes pre-ignition, destructive knocking, and accelerated wear on valves, piston rings, and cylinder liners. The Mainspring generator switches between natural gas, biogas, and hydrogen without shutting down. The company's published commercial specification sheets document this as a standard operating feature, not a laboratory prototype capability. The reason it works goes directly back to the mechanical simplicity. Because there are no spark plugs timing a precisely sequenced detonation, no intake and exhaust poppet valves cycling open and closed thousands of times per minute, and no piston rings scraping against cylinder walls, the system adapts to different fuel chemistries by electronically adjusting the compression ratio and charge timing in real time through its digital control unit. Think of it like a high-quality thermos flask. It does not care whether you pour in coffee, tea, bone broth, or ice water. The container functions identically regardless of the contents. The Mainspring generator does not care whether the molecules entering the combustion zone are methane, a 50-50 methane carbon dioxide blend from a cow manure digester, or pure hydrogen. It compresses the charge. The mixture auto-ignites at the correct pressure. The magnet assembly moves. Electricity flows out the terminals. That fuel agnosticism does something no fixed fuel generator can do. It protects your capital investment against fuel market disruptions for the entire 20-plus year operational life of the unit. Natural gas prices spike? Switch to biogas. Green hydrogen becomes regionally available at $2 per kilogram? Feed it hydrogen. Your machine does not care, and you do not need to buy a new one. And when you see what the maintenance calendar looks like compared to the generator on the concrete pad behind your house, you will understand why this technology threatens an entire dealer service network built on selling you oil filters and spark plugs. The lineage of this technology goes back nearly a century, and understanding it builds confidence that this is not vaporware. Free piston engines were first patented in the late 1920s. Raúl Pateras de Pescara, a Spanish-Argentine engineer, filed a foundational free piston engine patent in 1928 that eliminated the crankshaft. The United States military tested free piston configurations in the 1950s for portable field power. General Motors built a free piston gasifier concept vehicle in 1956, the XP500 Firebird II. The physics has been demonstrated for almost 100 years. What changed is three converging technologies. First, modern neodymium iron boron magnets, commercially available since the mid-1980s, deliver magnetic energy densities 10 to 15 times greater per kilogram than the ferrite magnets available in the 1950s. Second, digital microcontrollers running feedback loops at tens of thousands of cycles per second can adjust compression timing in microseconds. Third, air-bearing surfaces engineered by the semiconductor and precision metrology industries now sustain continuous industrial operation with bearing gaps measured in microns. Mainspring Energy was co-founded in 2010 by Shannon Miller, Adam Simpson, and Matt Sverchek, all trained at Stanford. In 2020, the company secured a major investment round from Bill Gates's Breakthrough Energy Ventures Fund. Khosla Ventures led an earlier round. Additional investors include Centaurus Capital and Fine Structure Ventures. Total disclosed funding exceeds $300 million, according to Crunchbase filings through 2023. That level of institutional capital does not flow into speculative science experiments. It flows into products with validated unit economics and signed customer contracts. Mainspring linear generators are producing electricity right now inside American businesses that cannot tolerate even brief interruptions. Kroger, the largest supermarket operator in the United States with nearly 2,800 stores, deployed Mainspring units at locations in California. A single Kroger superstore can carry an electricity bill between $10,000 and $18,000 per month, driven overwhelmingly by refrigeration compressors running 24 hours a day. A grid outage does not just mean the lights go out. It means perishable inventory worth $40,000 to $80,000 per store begins spoiling within hours. Kroger needed on-site generation that runs continuously, meets California's South Coast Air Quality Management District emission standards, and does not generate the noise complaints a bank of trailer-mounted diesel generators would guarantee from residential neighbors across the parking lot. The Mainspring units met every criterion. They sit on a concrete pad near the loading dock, operate at conversational volume levels, and produce clean, grid-synchronous alternating current. Microsoft represents another major validated deployment. The company has tested Mainspring systems at data center sites as part of its public commitment to eliminate diesel backup generators entirely by 2030. Data centers require what the industry calls 5 nines reliability, meaning 99.999% uptime. The Ponemon Institute's 2022 cost of downtime study estimated that every minute of unplanned data center downtime costs between $5,600 and $9,000 on average. The Mainspring system's near total elimination of mechanical wear parts directly targets that reliability threshold. Mainspring's published data states maintenance intervals measured in thousands of operating hours rather than the 250-hour intervals standard for reciprocating engines. Over a 10-year operating life, the cumulative maintenance cost savings on a commercial installation can exceed $50,000 compared to an equivalent capacity bank of conventional generators. That is not a marginal improvement. It is an order of magnitude shift in total cost of ownership. And this is where you start to realize that the money you have been spending on generator upkeep is really a maintenance tax on a 19th century mechanical architecture that never needed to survive into the 21st. So if this technology works, and it provably does at commercial scale, why has your electrician never heard of it? Why is it absent from every residential product catalog? The answer, as it almost always is with proven but non-mainstream energy technology, is structural. The federal incentive framework for distributed generation in the United States was built around two specific technology categories. Category 1 is solar photovoltaic, supported by a 30% investment tax credit under the Inflation Reduction Act of 2022. Category 2 is battery energy storage, which now qualifies for the same 30% standalone credit. Linear generators fit neither definition. They are not solar. They are not electrochemical storage. They consume fuel, which means the EPA and state-level air quality agencies classify them as combustion sources, even though the Mainspring system operates without an open flame, without a conventional exhaust manifold, and at emission levels below the thresholds of most permitted natural gas appliances. That combustion source classification triggers new source review permitting in stringent air quality districts like California's South Coast AQMD. The permitting timeline runs 6 to 12 months and costs tens of thousands of dollars in engineering documentation and filing fees. A rooftop solar array with a battery in the same jurisdiction can be fully permitted in 2 to 4 weeks for a few $100s. The regulatory system does not reward the best performing technology. It rewards the technology that matches the existing paperwork templates. Building codes compound the problem further. Residential and light commercial codes reference NFPA 37 for stationary combustion engine generator installations, and international mechanical code chapters written for conventional reciprocating engines, gas turbines, boilers, and furnaces. A flameless linear generator riding on air bearings with no oil system, no cooling radiator, and no conventional exhaust stack does not correspond to any existing code section. When a building inspector encounters equipment with no matching checkbox on the inspection form, the default response is either denial or a requirement for a custom third-party engineering review costing $3,000 to $10,000. The Inflation Reduction Act did include new provisions for clean hydrogen production tax credits under Section 45V and biogas pathway credits. But those credit structures assume the end-use technology is either a proton exchange membrane fuel cell, a solid oxide fuel cell, or pipeline injection equipment. A linear generator burning green hydrogen or upgraded biogas sits in a regulatory category that does not yet officially exist at the federal level. And here is the part that ties it all together. On-site generation that runs 24/7 on flexible fuel directly cannibalizes the utility business model. Every kilowatt hour you produce on your own property is a kilowatt hour your utility cannot bill you for. The Edison Electric Institute, the national trade association representing every major investor-owned electric utility in America, published a landmark report in January 2013, explicitly warning its members that distributed generation posed a disruptive threat to utility earnings per share. Their recommended countermeasure was not to compete on price or service quality. It was to lobby state public utility commissions for higher fixed monthly charges and demand charges that penalize customers who reduce their grid consumption. That is not conjecture. That is their own published strategy document. The system was not designed to suppress better technology. It was designed to protect revenue from the technology it already financed. Anything that does not fit the mold is structurally invisible. Now, here is where you need actionable, practical numbers, delivered honestly. As of 2024, Mainspring Energy sells exclusively to commercial and industrial end users. The company has not published a retail per-unit price, but energy analysts at Wood Mackenzie and Bloomberg New Energy Finance have estimated installed costs at roughly $1,000 to $1,500 per kilowatt for commercial-scale deployments. For a single 230 kilowatt unit, that puts the total installed figure somewhere between $230,000 and $345,000. That is not a residential price point, and I will not pretend otherwise. But here is exactly why it matters for your 5-year and 10-year planning. Every manufactured energy technology follows a learning rate cost curve once production volume ramps. The Department of Energy's Sunshot initiative documented that utility-scale solar fell from over $5.50 per watt in 2008 to under $1 per watt by 2020. Lithium-ion battery packs dropped from $1,100 per kilowatt-hour in 2010 to $139 by 2023, per Bloomberg New Energy Finance data. That is an 87% cost decline in 13 years. Mainspring is currently scaling manufacturing at a production facility in San Jose, California. As production volume grows and competing linear generator designs enter the market from companies like Itagen's spin-offs and academic commercialization programs, the cost per kilowatt will follow that same proven industrial learning curve. If you are designing an off-grid or grid-resilient property within the next decade, this technology category belongs in your system architecture plan now. In the meantime, take 4 concrete steps. First, study combined heat and power, known as CHP or cogeneration. The Mainspring system produces recoverable waste heat alongside electricity. Capturing that thermal output for domestic hot water, radiant floor heating, or greenhouse climate control pushes total system efficiency from 35 to 40% electrical, up to 80 or even 85% combined, according to the DOE's CHP Technical Assistance Partnership Program. Second, contact your state energy office and ask specifically about distributed generation incentives for non-solar, non-battery technologies. Connecticut offers its Residential Renewable Energy Solutions program. New York runs the NY Sun and Clean Heat programs. Massachusetts has a Connected Solutions program and has funded micro-CHP pilot installations. California's Self-Generation Incentive Program, known as SGIP, has historically covered fuel cells and advanced generation technologies. Third, if you own rural property with access to livestock waste, food processing byproducts, or a nearby landfill with a gas collection system, you already possess fuel. Dairy operations producing manure from 300 or more cows typically generate enough biogas through anaerobic digestion to fuel a 50 to 100 kilowatt generator continuously. The American Biogas Council's project directory lists over 2,300 operating biogas systems in the United States. Fourth, bookmark the Department of Energy's Combined Heat and Power Installation Database, maintained by ICF International. It maps every CHP project in the country by state, fuel type, prime mover technology, and nameplate capacity. Use it to identify contractors and engineers within driving distance who have real experience installing on-site generation beyond solar panels and battery walls. Avoid any installer who tells you your only choices are photovoltaic panels, lithium batteries, or a Generac. That is not expertise. That is a 3-item menu. 2 limitations deserve plain acknowledgement. First, the current Mainspring unit at 230 kilowatts is dramatically oversized for a single household averaging 30 kilowatt hours of daily consumption. Until Mainspring or a competitor ships a unit in the 5 to 25 kilowatt residential range, direct home installation is not feasible. Second, the machine requires a continuous fuel supply. It is not a renewable energy source in the way solar or wind is. If your goal is absolute zero fossil carbon emissions, this system does not satisfy that goal unless every molecule of fuel entering it is certified green hydrogen or waste-derived biogas. It eliminates your grid dependence, but it substitutes a fuel supply chain. Know that trade-off before you plan around it. So that is the complete picture, with verified numbers on the table. On one side, a conventional reciprocating generator with hundreds of moving parts, mandatory oil changes every 10 days of continuous runtime, 30 to 35% fuel efficiency, a 75 decibel noise output, and a decade-long maintenance bill exceeding $10,000. On the other side, a machine with essentially one moving part, a magnet assembly floating on air, no flame, no spark plugs, no oil, the ability to switch fuels without shutdown, and over $300 million in backing from investors who correctly bet early on lithium, solar manufacturing, and electric vehicles. Kroger stakes perishable inventory worth tens of thousands of dollars on it. Microsoft trusts it with data center uptime worth thousands of dollars per minute. And the annual maintenance savings alone at commercial scale can top $50,000 compared to conventional generators. If you want to power, heat, and cool your home off-grid, the Passive House files show you how. Full plans, exact materials, and the honest numbers nobody else gives you. It's not too late to start lowering your bill. Scan the QR code and see for yourself. So here is my question for you. If a residential-scale Mainspring linear generator hit the market at $10,000, would you buy it right now and run it on natural gas today? Or would you wait for it to qualify for a 30% federal tax credit that might never come? I genuinely want to know which way you lean, so drop your answer in the comments. Subscribing and sharing is the single best way to help this channel keep finding technologies like this before the mainstream catches up. Next time, we are looking at a thermoelectric generator that pulls usable electricity directly from temperature differences across a single metal plate. No magnets, no fuel, no moving parts at all. That one is going to change how you think about every warm surface in your home.